Today is the 14th of the 6th, 2023, and I'd like to introduce you to prime and composite numbers. Okay, let's consider numbers, factors of numbers from 10 to 20. Factors is very important, and we've done factors. I showed you how to do factors in the earlier videos. Okay, learning how to do it is very, very important. The factors of 10 is 1, 2, 5, and 10. Factors of 11 is 1, 11. Factors of 12 is 1, 2, 3, 4, 6, 12. Factors of 13 is 1 and 13. Factors of 14 is 1, 2, 7, and 14. Factors of 15 is 1, 3, 5, 15. Factors of 16 is 1, 2, 4, 5, 16. Factors of 17 is 1, 17. Factors of 18 is 1, 2, 3, 6, 9, 18. Factors of 19 is 1, 19. Factors of 20 is 1, 2, 4, 5, 10, and 20. Now, if you look at what we've done carefully, you can see that 11 has two factors, 1 and 11. 13 has two factors, 1 and 13. 17 have two factors, 1 and 17. 19 has two factors, 1 and 19. So, the numbers that have two factors are called prime numbers or prime factors. Okay? 11, 13, 17, 19. They have only two factors, and the factors are 1 in itself, the other number. So 11, 13, 17, 19 are called prime numbers. Very important, don't forget. And you can get some prime numbers from 2 to 9. And then the others, 10, 12, 14, 15, 16, 18, 20 are called composite numbers. So prime numbers have only two factors, the number itself and 1. Example 11, as we found out. The other numbers, example 12, 10, are composite numbers because they have multiple or more than one, more than two factors. Is that okay? Note, 1 is a special case. 1 is not a prime number and is not also a composite number. Okay, composite numbers as a product, if I'm talking mass product, it means multiplication. Okay, so if you see products in mass, it is looking at multiplication of prime numbers. So for example, we just realized that 12 and 15 are 12 is a composite number. So 12 is equals to, which from your timetable is 4 times 13. And when you break it down, the 4 further, you get 4, 2 times 2 times 3. So 2, 3, 2 are prime factors. 15 equals 3 times 5. So 3 times 5 are prime factors. So 2, 3, 5, all these are prime numbers. So if you break a number down, the final stage should be giving you prime factors. Okay, I hope I'm clear. Note, prime factors are different from ordinary factors. Okay, so 6 can be a factor of 36, but it's not a prime factor. 2 and 3 are prime factors because they are prime numbers. I hope I'm making some sense here. Let's quickly look at another example. So when you look at example, composite numbers has only one set of prime factors. Okay, so 36, when you break it down using your multiplication times table, is 3 times 12. But 12 is not a factor. It's not a prime factor. So we want to break it down further. So we still have 3. 12 becomes 4 times 3. And we realize we can break 4 down to 2 times 2. So now we have 3. Our 4 becomes 2 times 2. And then we have 3. So 36 now is 3, 2, 3, 2. Okay, so now 2 and 3 are prime numbers, so they are prime factors. So we have 2 of 2's, which is 2 to the power 2, and we have 2 of 3, which is 3 to the power 2. I hope I'm making sense. Okay, if you don't understand, just watch it over again. If you understand the concept of factors, then this should be a bit easier. That's why I introduced that topic earlier. Now, the prime factor tree. Let's consider the number 48. Okay, mass has to do with numbers a lot. Okay, now 48 using our multiplication is 6 times 8, but we want to break them down into factors. Okay, and we can break them down further. So 6 here will give us 2 times 3. 4 will give us 4 times 2. We can't break 2 down any further because now 2 is a prime number, 3 is a prime number, but 4 is not. So we are breaking 4 down to 2 times 2, and then we have another 2. So now our prime factors are 2 times 3 times 2 times 2 times 2. That we have 1, 2, 3, 4. So we have 2 to the power 4 times 3. Okay, so these are the prime factors of 48. Now we can express this as a tree. So I'm going to quickly show you how to do that. Okay, I don't want my video to go too long. So the prime factor tree for 48 will look like this. So 48 times, we first have 8 times 6. Okay, we can break them down further. So 8 becomes 2 times 4. 2 now is a prime number, but we can break 4 down further, which is 2 times 2. Now we can still break 6 down further, which is 3 times 2. So how many 2's do we have? 1, 2, 3, 4. 2 to the power 4, and then we have only 1, 3. So these are the prime factor tree. That was how it would look like. And so 48, we've broken it down to prime factors. Prime factors means factors that are prime numbers. 2 and 3, 4 are prime numbers. So now we have 2 times 2 times 2 times 2 times 3. So it is 2 to the power 4 times 3. There are times I might be saying 125 and I'll say 25. But carefully look at what the video and see the number I've written. I might be saying the square root of 16 is 4, and I accidentally say the square root of 14. If I catch myself, I'll quickly say the square root of 16, or pardon me. My videos are not edited, so if you watch it and you are not sure, just look at the scripts that I've videoed. Okay, and then you should be. Today's lesson, we've looked at prime and composite numbers. Okay, and then we've also looked at prime factors, and I've just inserted the prime factor tree to help you. Okay, so hopefully enjoy watching this video, and I'll see you in the next lesson, and thank you for watching.